When adding a subpanel in a residential setting with a 120/240 volt system and repurposing an existing range circuit conductor, specifically an 8/2 cable with a bare ground/neutral, the question arises where to connect the bare conductor within the new subpanel. In older electrical installations, it was common practice to use the bare conductor as both the equipment grounding conductor and the neutral conductor for the range circuit. However, current electrical codes require a clear separation between the neutral and grounding systems in subpanels. The critical point is that in a subpanel, the neutral bar and the ground bar must be kept separate. This separation ensures that fault currents have a dedicated path back to the main service panel, minimizing the risk of electrical shock and ensuring proper operation of overcurrent protection devices. Therefore, when feeding the subpanel with the repurposed range circuit, the bare conductor, which previously served as both ground and neutral, must now be connected to the ground bar in the subpanel. The neutral conductor for the subpanel must be run separately from the main panel, and it should be insulated. To reiterate, the bare conductor should be connected to the ground bar in the subpanel. The reason for this lies in the fundamental principles of electrical safety and grounding. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid tripping of the circuit breaker or fuse, thereby interrupting the flow of electricity and preventing a dangerous voltage from being present in the metal parts of electrical equipment. Connecting the bare conductor to the ground bar ensures that any fault current will have a direct and safe route back to the main panel. If the neutral and ground were bonded together in the subpanel, it would create a parallel path for the neutral current to flow on the grounding conductors. This can lead to several problems, including objectionable neutral current on the grounding system, which can interfere with sensitive electronic equipment. Also, it can create a shock hazard if the grounding conductors become energized. To elaborate, the separation of the neutral and ground at the subpanel is essential for maintaining a safe and reliable electrical system. The neutral conductor carries the imbalanced current from the loads back to the source. The grounding conductor provides a path for fault current to return to the source. By keeping these two functions separate, you minimize the risk of electrical shock and ensure the proper operation of the overcurrent protection devices. When installing a subpanel, it's crucial to follow all applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and protect people and property from electrical hazards. Specifically, the National Electrical Code, or NEC, provides comprehensive guidelines for electrical wiring and equipment. Article 250 of the NEC covers grounding and bonding requirements, and it provides detailed instructions on how to properly ground electrical systems. When installing a subpanel, it's important to pay close attention to the requirements for grounding and neutral separation. The NEC requires that the neutral conductor be isolated from the ground conductor at the subpanel. This means that the neutral bar and the ground bar must be kept separate, and there should be no electrical connection between them. The only point where the neutral and ground are bonded together is at the main service panel. The reason for this is to prevent neutral current from flowing on the grounding conductors. Neutral current is the current that returns to the source on the neutral conductor. If the neutral and ground were bonded together at the subpanel, some of the neutral current would flow on the grounding conductors. This can create a shock hazard and interfere with the operation of sensitive electronic equipment. In addition to separating the neutral and ground, it's also important to properly size the grounding conductors. The size of the grounding conductors must be adequate to carry the maximum fault current that could occur on the circuit. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the circuit conductors. When installing a subpanel, it's also important to use the correct type of wiring. The wiring must be suitable for the application and must be installed in accordance with the NEC. For example, when running the feeder conductors from the main panel to the subpanel, it's important to use a cable that is rated for the voltage and current of the circuit. It's also important to use the correct type of conduit or cable tray to protect the wiring from physical damage. Before beginning any electrical work, it's important to disconnect the power to the circuit. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It's also important to use a voltage tester to verify that the circuit is de-energized before working on it. When working on electrical circuits, it's important to wear appropriate personal protective equipment, or PPE. This includes safety glasses, gloves, and insulated tools. Safety glasses will protect your eyes from flying debris, and gloves will protect your hands from electrical shock. Insulated tools will help to prevent accidental contact with energized conductors. It is also advisable to consult with a qualified electrician if you are unsure about any aspect of the electrical work. Electrical work can be dangerous, and it's important to take all necessary precautions to ensure your safety. A qualified electrician will have the knowledge and experience to perform the work safely and in accordance with all applicable codes and regulations. Firstly, ensure that the subpanel is properly sized for the intended load. This involves calculating the total amperage of all the circuits that will be served by the subpanel and selecting a subpanel with a sufficient ampacity rating. Secondly, install a separate grounding electrode system for the subpanel if required by the NEC. This typically involves driving one or more ground rods into the earth near the subpanel and connecting them to the ground bar with a grounding electrode conductor. Thirdly, bond all metal parts of the subpanel enclosure to the ground bar. This ensures that any fault current will have a low impedance path back to the source. Fourthly, use a 4-wire feeder to supply power to the subpanel. This feeder should consist of 2 hot conductors, a neutral conductor, and a grounding conductor. The neutral conductor should be insulated and should be kept separate from the grounding conductor throughout the entire run. Fifthly, terminate the grounding conductor on the ground bar in the subpanel. Ensure that the connection is tight and secure. Sixthly, terminate the neutral conductor on the neutral bar in the subpanel. Ensure that the connection is tight and secure. Seventhly, do not bond the neutral bar to the ground bar in the subpanel. This is a critical step that is often overlooked. Bonding the neutral and ground together in the subpanel will create a parallel path for neutral current, which can lead to objectionable neutral current and a shock hazard. Eighthly, label all of the circuits in the subpanel clearly. This will make it easier to identify the circuits in the future and will help to prevent accidental overloading. Ninthly, test the subpanel to ensure that it is properly grounded. This can be done using a multimeter to measure the resistance between the ground bar and a known ground point. The resistance should be very low, typically less than 1 ohm. Tenthly, inspect the subpanel regularly to ensure that all of the connections are tight and secure. Also, look for any signs of damage or corrosion. If you find any problems, correct them immediately. In summary, when repurposing the range circuit, connect the existing bare wire, which served as both equipment ground and neutral in the older installation, to the ground bar within the subpanel. Remember to run a separate insulated neutral conductor from the main panel to the subpanel's neutral bar, keeping the neutral and ground systems isolated in the subpanel itself. This approach ensures adherence to modern electrical codes and promotes electrical safety.